I'm going to give a short talk on behalf of Dick and myself. I think really, Chris is showing this near-term possibility that much can be integrated at the wafer scale as the end of this talk. And yet, in addition to that, we want to make sure everything is integrated. So we have had this very practical team led by Dick and myself who have been in this building doing this work. And I just wanted to give you a brief update of that. Here's a long shot of this lab, which is quite expensive. And next to it is the pump that I mentioned before with this sensor on the top. So the first job in doing this work just before the summer was to do a very good characterization of these pumps. There are 3 of them in the basement area. And the first thing you want to do, of course, is measure the characteristics of a healthy pump. And then later on, at some point, there's going to be a failure, so that this is a generic curve of wear on the y-axis against time. And generally speaking, in most mechanical systems, whether it's a very large power plant, the car you drive, or sad but true, even the body that you occupy, will do something like this. So they'll be running in wear, right, where my grandchildren are running in their wear right now. Hopefully, through most of your life, there'll just be this general steady state wear. And then, unfortunately, for all of us, there'll be some event that begins to make our wear mechanism go more rapidly. And so what all these sensors are going to try and do for power plants or for any other mechanical equipment is to try and figure out where we are in this wear process. Now, I will say, and I sound like a car salesman when I say this, we did put these devices on the pumps downstairs, and by Jove, we actually predicted that one of these pumps was going to fail. So that was a very gratifying activity. And by doing that, we've actually begun to equip this building with some of the nice sensors that we've been building through the project. So this is our experimental setup. It's a bit of a laundry list of activities on this slide. You see that we've been using the standard motes that have been available from Texas Instruments for some time. The harvester that, which I'll show you, has been tuned. Actually, that's one thing about the harvesters. We've always tuned them to the devices that we've placed them on. Lindsay Miller graduated, and she did some nice work to look at harvesters that will change according to the vibration spectra of the devices we've put them on. But for now, for these practical applications, it's been better for us just to tune them to the devices, the environment, I should say. The energy from the harvester has been stored on this very, very large capacitor. And then just making it clear, we're using a vibration system to harvest the energy, and then we're using a supplementary MEMS accelerometer to measure the characteristics of the pump. For Domenico, we've been setting up these webcams as well, so he can see what's going on down in the basement. The mode goes from being continuous and then sleeping between samples. And here's just some various things that are on the slides that you can get to show the transmission and activity rate. I think I showed these curves before, these photographs before. This is just a very nice setup of the device that Andrew Waterbury built. This is similar to a voice coil that you would use in your hi-fi system, and that's moving the coil backwards and forwards. And as the pump and any mechanical system generally vibrates, this system has a clear coil in there, and you can feel it vibrating. I forgot to bring one in, but I'll bring one in after lunch. The setup on the pump, again, is shown here, and these are the electronic devices shown at the back. Funny, actually, look at this. It doesn't look too different to the device that Igor showed for the gas sensing work that we showed before. So the scavenger does its thing of vibrating with the system and gathering the energy and putting it into a capacitor. And this is the main slide I wanted to show, where what we've been doing is sending 7 packets out from the system, seven wireless packets before the system charges up again. So this blue curve is just time along the bottom, and it's energy. And so the vibration harvester is working away. It's gradually charging up the capacitor, and then boom, boom, boom on these 7 side steps here, we begin to send out the wireless signals based on the microcontroller, the TI mode that I mentioned, and this is sending out the vibration data for the pump and characterizing what the analysis of the pump is doing. So as we begin to, as the pump begins to wear, what we notice is that these signals obviously become larger, and we had to have a cutoff to the vibration analysis. And as the pump considerably started to wear, there were other vibration peaks that began to occur in the FFT analysis, because as just like on an old car that you may have driven many years ago, as things start to vibrate, other issues come in where you'll start to vibrate, and other parts of the vehicle begin to deteriorate. So as the vibrations become quite intense, then the other parts of the pump begin to deteriorate too. So that's pretty much the main thing I wanted to say. As we charge and send individual packets, this is just a close-up of those stair steps that I showed you before, and you can see that there's sort of 4 to 5 volts is the kind of charging and packet rate that we get from the harvesters. And I think that's my last slide. I wanted to end on that and just emphasize that these are systems that we have working, and tying it back to Chris's talk and now to Jim's talk, we're taking these integrated systems and reducing them to the wafer scale as we go forward in the work. So that was really what I wanted to conclude on. Thank you. How about I take one quick question if necessary, and then hand over to Jim to give him plenty of time before the lunch break. Right. Yes, sir.
What kind of advance notice are we looking at when one has to actually be replaced?
I would say we were beginning to see these deteriorations, so that certainly within a week period of the pump operating, we began to see that things were not great.
So it's within the replacement time period, a realistic replacement time period?
Yes.
Okay,
yeah.
Thank you.
In fact, I could go into this for a bit of time, but I think what's in the back of your question, there's no point in knowing about the failure when it's either just happened or about to happen. Right? You need plenty of time. Tony.
How do you deal with the inconsistency of vibration of mechanical systems? I mean, some of those motors may be perfectly balanced and you won't be able to get the vibrations off of them. Do you whack them with a hammer to throw them off a little bit so you have something to scavenge, or do you...
Actually, that's not quite right. I mean, most mechanical systems, even the most finely tuned system, will give vibrational characteristics, and you can harvest them. I mean, I appreciate your comment, but you don't have to do anything to deteriorate. Next time you're on a plane or on a... It's quite... Actually, just to close with something humorous, if you stand near a large glass window on Shattuck Avenue, because we do our work at the Berkeley Wireless Research Center, and if you just carefully put your finger on the pane, as the buses are going by, you'll see the pane. You'll feel the pane, the glass pane vibrating. I'm sorry. Obviously, it's time for me to sit down, but you can feel it. Tony, thanks for the good question. Best to hand over to Jim now before I make more of a fool of myself with this. So, thank you.
Are you no longer using the microphone?